Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concept related to the Simulink. In the previous tutorial, we have seen what are the different type of solvers that are available in Simulink, how you can choose between the fixed solver and the variable solver. Along with that, we have also seen what is maximum sample time and minimum sample time, the initial sample time in the configuration window for the Simulink model. In the previous tutorial to that, we have created this particular model which is on the screen. We have created a staircase signal which is getting generated with the help of this model. So suppose you want to create a counter, we'll just count up to a certain value. After that, it will just reset back to the value of 0 and again it will start counting. Such type of modeling questions is being always asked in interviews, and let's see like how we can design the same. So let's develop the or improve the model that is on the screen. For that implementation, we will be deleting the signal line and we will be adding a switch block. So basically the switch block is a block which has 3 inputs. So basically now let's connect it to the relevant port. So we will be using a relational operator, and this relational operator will tell like whether we are below value of 5 or not. So here our reset value will be like 5. So we will check whether the value that we are receiving is above 5 or not. If it is trying to go above 5, then we will be resetting it back and we will be setting it to 0. So that is the main objective over here. So let's arrange the blocks in a proper way. So relational operators takes 2 input, and whatever the relation that is mentioned in the block, that relational operation will be performed, and it will give either a logical output 1 or 0. Here 1 means true and the 0 means false. So in this case, if you see, if the signal value is going above the value of 5, then you will be taking the output from here, like from this line. So we will be connecting this block, and here we will be setting it to 0. Once we set it to 0, and we will be connecting it. So let's see like how these things works. So here, if the value of the signal, that is the main signal line over here, if it is above 5, so if it is rising above 5, like or if it is equal to 5 also, then in that case this value will be set to true. The outcome that will be there from this particular line. Okay, and once the value becomes 0, then it will be updated here again. So this will be 0 again, this will be 2, then this value will reset back to 2, and then in the next time step it will increase further until it reaches to the value of 5. So basically here we will be using 1 to avoid all these contradiction, because we cannot count it properly if we used to. So we will be using 1 over here, and then once the value goes below 5, then this outcome will be false, and the signal will be transmitted from this port. It will not be transmitted from this port. So let's see all these executions into picture. Okay, now we need to give a proper description for the same. So this is this is a counter program, and that will be reset after a defined count is being reached, and that specific count in this particular model is 5. Okay, it will count till 5, and now let's simulate this model. So if you click on the relevant lines, then you can see this value is true. Yes, so when it is true, we will be taking so the relational operator that is being used is wrong in this case. So we need to switch, because we need to operate this particular switch in a required way. So now 2 is less than 5, we are getting the false, but yeah, as the increment, if we do better in 1, then we will be able to reach to 5 also. So because of that, we changed the constant input as 1 now. If we just simulate the model step by step, you can see the values are changing, and till it reaches 5, it is updating, but after that it is resetting back. So now as it was reaching till 4, because we used the less than equal to operator, now we changed it to 6, and now we are able to count till 5. And here you can see the counter is getting reset at every time when it is reaching to 5, and that is how this particular simulation is working with the help of this switch block. So basically, in the staircase signal model, if you add the switch block with the relevant inputs, then you can generate this type of signals. And this is mostly being asked in interview questions, like how you can generate some staircase signal. Like you can also change the number till what point you want to count, and again it will get reset back. So that is how you can use it. You can use the limit that is for now 5. You can increase that limit to some other value by assigning it to a variable, and you can change that value over time. So through that, you can also create a variable counter, like every time it will update to a defined value, and then you will be counting till that value, and then again resetting back to 0, again counting to that number itself. So that is how you can create a staircase type of signal. And yeah, that's all about this particular tutorial. The main intention over here is to show you the changes that we did from the previous model, and we just updated the response for the model. And this is how small improvements will lead to a good model, which you will be using like in developing any future projects. So start with the basic model and then try to improve it over time. Then you will be reaching to a complex model. This is more complex than the previous one. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. This will be like more helpful for us to improve the content in the channel, and also will give you a proper guidance for learning MATLAB in this channel. So have a great day ahead. Thank you, and happy learning MATLAB.